Control statements are like traffic lights. They determine when a program should go, stop, or even change direction. These statements help us control the flow of code execution based on different conditions or needs. In programming, we often need to make a decision between two actions based on a certain condition. For example, turn on an LED when a button is pressed, otherwise turn it off. Start a fan when the temperature is too high, otherwise keep it on standby. This kind of either-or decision can be implemented using an if-else statement. The core feature of if-else is that only one block of code will be executed per evaluation. Like reaching a fork in the road, you must choose one path. The else part is the default path of the if statement. It doesn't require an additional condition and automatically handles all cases not covered by if. Take controlling an LED with a button as an example. When the button is pressed, the program executes the if block and turns on the LED. When the button is released, it automatically switches to the else block and turns off the LED. This kind of logic is very common in hardware interaction and is a fundamental way to implement binary control. In addition to conditional statements, loop statements are also essential tools in programming. They allow us to automatically and repeatedly execute a block of code until a certain condition is met or no longer holds true. The most commonly used loop statements are the for loop and the while loop. When we clearly know how many times the code needs to be executed, the for loop is the most suitable choice. It consists of three parts: initializing a variable, checking a condition, and updating the variable, usually written on a single line for a compact and clear structure. For example, in the following code, the variable I starts from 0 and increases by 1 with each loop iteration, stopping when it is no longer less than 10, which results in a total of 10 executions. The for loop is ideal for tasks that need to be repeated a fixed number of times, such as making an LED blink 10 times, rotating a motor 5 turns, or processing a batch of sensor data. In programming, there are situations where we don't know in advance how many times a task should repeat. We just want it to keep running as long as a certain condition holds true. In such cases, the while loop is the right choice. Unlike the for loop, the while loop doesn't require a predetermined number of iterations. This makes it more flexible when dealing with tasks that rely on real-time condition checks. As long as the condition remains true, the loop continues to execute. For example, in the code below, the LED stays on as long as the ambient light level remains below a defined threshold. Once the light becomes stronger and the brightness reading exceeds the threshold, the condition is no longer met, the loop ends, and the LED turns off automatically. This logic simulates the behavior of an automatic night light. The light turns on when it's dark and off when it's bright. This section introduces the basic usage of if-else conditional statements and for and while loops. Conditional statements allow a program to perform different actions based on different situations, while loop statements are used to repeat a block of code. In the next lesson, we will dive into more exciting content, the use of sensors, taking the first step in perceiving the outside world.